So in this video we're going to look at finding and interpreting the intercepts of a linear model. So for this first example we have a function that allows you to input a temperature in Celsius and convert that temperature into a temperature in Fahrenheit. We are asked to find and interpret the intercepts of the model. This is a graph of the model right here, and we want to recognize that the output variables f are going to be plotted on the vertical axis, and the input variable c is going to be plotted on the horizontal axis, and the intercepts are going to be where we cross the vertical or Fahrenheit axis and where we cross the horizontal or Celsius axis. And we're being asked to find these crossings and then interpret what they mean in the context of the model. What we want to notice is that the vertical intercept, the Fahrenheit intercept, corresponds to a Celsius temperature of 0, and what we're being asked to do is to find the Fahrenheit value that goes with it. So the vertical intercept is the easiest to do because we have a model that's in slope intercept form, which means that we can read the vertical intercept directly from the model. The vertical intercept is the 32. So for this model, if we have a temperature of 0 degrees Celsius, it's going to correspond to a Fahrenheit temperature of 32 degrees Fahrenheit. And this is going to be the Fahrenheit intercept or vertical intercept. And then all we need to do is interpret that intercept in the context of the model. So that's just simply saying what the intercept means in words. So for example, we could say that a temperature of 0 degrees Celsius corresponds to a temperature, sound it out, of 32 degrees Fahrenheit. And then typically when you get an intercept and you write down the interpretation of the intercept, you want to make sure that that intercept makes sense, because what we're going to see in the next example is that sometimes the intercepts are garbage or junk. They don't give us useful information. In this case, this intercept does give us useful information. 0 degrees Celsius and 32 degrees Fahrenheit are in fact both the freezing points of water. So this is an intercept that makes sense. Then we need to find the horizontal intercept. So again, Fahrenheit, Celsius. The horizontal or Celsius intercept is going to be located right here. And what we want to notice is that as we cross the Celsius axis and try to figure out what Celsius temperature is there, we can see that the Fahrenheit has to be 0. So on the horizontal intercept, the output is always 0. So if we're looking to find the Celsius, spell it with an S, Celsius intercept, what we want to recognize is that the Fahrenheit temperature has to be 0 as we cross the Celsius axis. So we simply go up to the model, replace F in the model with 0, and set that equal to 9/5 of the temperature in Celsius plus 32. Subtract this 32 from both sides. Multiply by the reciprocal of the coefficient on the Celsius variable. So multiply by 5/9 on both sides, because 9 divided by 9 is 1, 5 divided by 5 is 1, and we get 1 times Celsius times 1 is just Celsius. And then if we multiply this, we're going to get what? Negative 160 over 9. And we could convert that if we wanted to into a mixed number if it gave us a better sense of what the temperature was. So we could say, hey, I'm going to put 9 into Oh, I better do that up high. If I get down in this corner, I get in trouble. So I could take the 160, divide it by 9. 9 will go into 16 once. That's going to leave us a 70, so we'll get 9 times 7 is a 63 with 7 left over. So we could also write this as, or we could write this as 17 with a negative in front of it because we have a negative here. Negative 17 and 7/9 degrees Celsius. And that looks like it's correct based on the location of that intercept on the axis. So finally what we need to do, get rid of a bunch of this stuff here. There we go, I killed it. What we need to do is give the intercept. So the intercept is negative 160 over 9 degrees Celsius, comma, corresponds to a Fahrenheit temperature of 0 degrees. And I think in the homework it always says give the intercept including units, or find the intercepts as ordered pairs including units. And the including units part of that statement means that you're being asked to include the measurement units on the numbers. And then we just need to interpret this. So the interpretation, right, because over here it says interpret. So the interpretation is that a temperature of negative 17 and 7/9 degrees Celsius corresponds to a temperature of 0 degrees Fahrenheit. And again, when we think about this, there's nothing nonsensical about this. Negative 17 degrees Celsius isn't an uncommon temperature. We looked at what the coldest possible temperature was in Celsius, and that corresponded to negative 200 and some odd degrees. So nothing about negative 17 degrees Celsius should bother us. In the next example, this is rainbow trout data that was taken from the Spokane River in Washington, and the ecologists who were doing the study discovered that they could project the weight of rainbow trout in the Spokane River if they knew the length of the trout. So they were able to give weight as a function of length for the trout in that river, and that model was roughly linear. This is a linear model that was constructed from putting a regression line to the data set. So again, to find the intercepts, we want to recognize that if the weight in grams, up here it says the weight is measured in grams, if the weight in grams is the output, that's going to be the vertical axis. It's going to be weight in grams. And then length are the inputs. So the length axis is the horizontal axis, and those lengths are being measured in millimeters. So length measured in millimeters. And we're being asked to find the intercepts again. So we have a length intercept. We have a length intercept, and we have a weight axis intercept right here. And I did that wrong, didn't I? So anyways, we want this intercept right here. The problem is when you try to make a point, the pin going in a circle brings up the menu. So I have yet to figure out how to defeat that. So anyways, we want to recognize that as we cross the length axis and try to figure out what number is there on the length axis, we want to recognize that the weight will be 0. And as we cross the weight axis, we want to recognize that at that intercept, the length will be 0, and we're trying to figure out the weight that goes with that. Again, because we have a model in slope-intercept form, it's going to be easiest to get the vertical intercept first, because the vertical intercept is part of the model. It's sitting right here, the negative 927.5. So the weight intercept is going to be given by an input of 0 millimeters, because we have 0 when we're on the input is 0 when we're on the vertical or output axis. And an input of 0 millimeters corresponds to a weight of negative, because of the minus sign right there, negative 927.5, and we need to include the units, so this is going to be negative 927.5 grams. And then the interpretation of that is a trout whose length is 0 millimeters will weigh negative 927.5 grams. And again, you always want to stop and then think about what the interpretation of the intercept is and identify whether it makes sense or not. And a 0 millimeter trout doesn't make sense, and a negative weight also doesn't make sense. So we want to identify that we understand that this intercept doesn't make sense. This intercept does not make sense. We expect trout to have length. We expect them to have length and to have a positive weight. So the negative weight doesn't make any sense. So that's the W intercept. To get the length intercept, which is right here, we want to recognize that we don't know what that number is, but that the weight is going to be 0 right there. This is the length axis again. This is the weight. Weight's measured in grams. Length is measured in millimeters. And the next intercept to get is the length intercept. And to find the length intercept, we need to understand that when we are crossing the horizontal axis, the output variable will be 0. So we need to identify that W is going to equal 0 as we cross this horizontal axis. So we take the model, we replace the W with 0, we set it equal to the 4.5 times length minus the 927.5, and we solve it for the length. So first step is add 927.5 to both sides. So we add the 927.5 to both sides, which will leave 4.5 times the length on the right hand side. Divide both sides by the coefficient on the length variable. 4.5 divided by 4.5 is 1. 1 times length is length. And then we get 927.5 divided by 4.5, which comes out to be 206.1 repeat, or you could write that as a mixed fraction as 206, and 0.1 repeat is the same as 1/9, and this is going to be 206 and 1/9. This is the length axis, so this is a length measurement, so these are millimeters. So coming up to the top here, writing the intercept as an ordered pair including units, I'm going to write 206.1 repeat millimeters, comma, corresponds to 0 grams. And my interpretation of that is that a trout whose length is 206.1 repeat millimeters has a weight of 0 grams. So again, we want to identify that this intercept doesn't make sense. There's a sense in which we can say it's junk, because a 206 millimeter trout isn't going to be weightless. But this intercept would be useful if we were trying to find, for example, the domain and range of this problem. And usually finding intercepts is part of the domain and range finding process. Sometimes the intercepts give you useful information. Sometimes they don't give you useful information, which is part of why we want to be able to interpret the intercepts to identify whether or not they are meaningful in the context of the application problem.